At the center of our galaxy, 26,000 light-years from here, there is a supermassive black hole 4 million times the mass of the Sun. For decades we knew it was there, but not how it was oriented, which way it was spinning, where it was aimed. In 2025, a new analysis of the most detailed black hole data ever taken gave us the answer, and the answer was unsettling. Sagittarius A star is spinning at almost the maximum speed physics allows, and its axis, the line it spins around, the direction anything it launches would travel, is pointed almost directly at Earth. In this video, you'll find out what that actually means, why scientists were surprised, and whether a black hole aimed at us is something we should be worried about. The real answer is stranger than either yes or no. First, what we're dealing with. Sagittarius A star is the supermassive black hole at the heart of the Milky Way. Every star you've ever seen, including the Sun, orbits around it. It contains about 4 million times the mass of our Sun, crushed into a region smaller than our solar system. We didn't always know it was there. We confirmed it by watching stars near the galactic center move, stars whipping around an invisible something at thousands of kilometers per second, on orbits that only make sense if they're circling an object of staggering mass. One star, called S2, comes screaming around it every 16 years. That work won a Nobel Prize. And in 2022, the Event Horizon Telescope did something that should have been impossible. It produced an actual image of Sagittarius A star, a dark shadow ringed by glowing, superheated gas, 26,000 light-years away. But an image tells you what something looks like. It doesn't tell you how it moves. And how this one moves is where the story turns. Because hidden in that data was a detail nobody could read until 2025. Black holes really only have two properties: how much they weigh and how fast they spin. We had the weight. The spin stayed hidden. It's extraordinarily hard to measure across 26,000 light-years. In 2025, a team led by Janssen used a machine learning system trained to pull faint signals out of the Event Horizon Telescope data, signals ordinary analysis left on the table. What it found: Sagittarius, a star, is spinning fast. Not just fast, near the theoretical maximum, around 80 to 90% of the absolute limit a black hole can rotate. At that speed, the black hole drags space-time itself around with it, warping the space nearby into a shape researchers compared to a flattened football, a near maximally spinning black hole at the center of our galaxy. That alone would be a headline. But it was the orientation that made people stop. Quick one while that sinks in. Drop a comment. When you picture the center of our galaxy, did you imagine it as calm or violent? Genuinely curious what people assume. Now, the direction it's aimed. Here's what the spin orientation means and why it matters. When a black hole spins, it defines an axis, an imaginary line through its poles, the same way Earth has a north and south pole defining its axis. For a spinning black hole, that axis is the most important direction there is. Anything the black hole launches, jets of energy, beams of particles, travels along that axis, out from the poles. The 2025 analysis found that Sagittarius, a star's axis, isn't pointing off to the side, along the plane of the galaxy, the way you might expect. It's tilted so that it points almost directly at us. The fit puts the axis angle close to our line of sight, meaning if you stood at the black hole's pole and looked straight out, you'd be looking roughly toward Earth. Now, your instinct on hearing that is probably alarm. A near maximally spinning, supermassive black hole aimed at our planet. It sounds like the setup for an extinction event. So let's deal with that directly, because the honest answer requires understanding one more thing about what this black hole is and isn't doing right now. The 2025 study found something else. The light near Sagittarius, a star, is dominated not by a powerful jet, but by extremely hot electrons swirling in the gas around it. Right now, our black hole is relatively quiet. It's not a raging quasar blasting energy across the galaxy. It's sipping, not feasting. But right now is doing a lot of work in that sentence, because Sagittarius A star has not always been quiet, and we have the evidence written into the gas around it. Genuine question before we go further. If our galaxy's black hole did wake up and become active, do you think humanity would even be able to tell from 26,000 light years away? Drop your guess in the comments. Here's where it goes from a curiosity to something genuinely eerie, because the black hole at the center of our galaxy did wake up, recently enough that, in a sense, we just missed it. In 2023, NASA's IXPE telescope, working with Chandra, found something remarkable in the gas clouds near the galactic center. Those clouds were glowing in X-rays, but not with their own light. They were echoing light that came from Sagittarius A star during an outburst about 200 years ago. 2 centuries ago, around the time of the early 1800s on Earth, our galaxy's black hole devoured something, flared brightly, and then went quiet again. The flash itself reached us long ago. What we see now is the delayed echo, bouncing off surrounding gas like thunder after lightning. So this black hole is not eternally calm. It cycles, it feeds, flares, and sleeps. So we have a near maximally spinning black hole, axis aimed roughly our way, that's capable of waking up. Why isn't this terrifying? Distance. Sagittarius, a star, is 26,000 light years away. That is an almost incomprehensible gulf. Even when it flared 200 years ago, the effect that reached us was a faint X-ray echo, detectable only by specialized telescopes. Not a death ray, not a pulse of destruction. Just light. For a supermassive black hole's activity to genuinely threaten Earth, we'd need to be vastly closer, and it would need to be vastly more active, blasting relativistic jets as a feeding quasar. Sagittarius A star is neither close enough nor active enough. The aimed at Earth headline is geometrically true and practically harmless. So if it's not a threat, why does the orientation matter so much? Because of what it tells us about our galaxy's history. The 2025 study noted that a spin axis pointing this way, rather than aligned neatly with the galaxy's rotation, carries information. The direction a black hole spins is a fossil record, shaped by everything it has swallowed over billions of years, and by whether it has ever merged with another black hole in a galactic collision. In other words, the angle Sagittarius A star is aimed is a clue to the entire violent history of the Milky Way's center. We're not in danger from it. We're reading it like a compass needle frozen in a direction that records where everything came from. Step back and hold the whole picture at once. At the center of our galaxy sits a black hole 4 million times the mass of the Sun, spinning at nearly the maximum rate the universe allows, warping space-time into the shape of a flattened football, with its axis aimed almost directly at the planet you're standing on. It woke up 2 centuries ago, flared, and went back to sleep, and we only learned the direction it's facing in 2025. None of it can hurt us. The distance is its own kind of mercy. But here's the part worth sitting with. Everything you are, every atom in your body heavier than hydrogen, the iron in your blood, the calcium in your bones, was forged in stars that lived and died in orbit around that black hole. It is the anchor the entire Milky Way turns around. We are not its target, we are its residents. And for the first time in human history, we can look 26,000 light-years into the heart of our own galaxy and see which way it's pointing. The most powerful object in the Milky Way is aimed at us, and all it's doing is showing us where we came from. If you want more of the objects quietly shaping our place in the universe, subscribe. I cover a new one every few days, and the next is stranger than this one. And speaking of objects aimed our way, the next video is about Oumuamua, the first visitor from another star, which passed through our solar system, accelerating in a way that, to this day, no one has fully explained. That one's up next.